seems like a review lesson, and if it doesn't, then really make sure that you focus on getting this down well, because this is an Algebra 1 skill that we are just expanding. So here we'll simplify, multiply, and divide rational expressions. So in Part A, just to make this point very clear about what we are doing, recall that in fractions we can cancel out things that are common factors. So what we really want to look for are factors, things that are multiplying each other, not terms. Like I can't just cancel an x with an x, especially when it's being added or subtracted to something else. However, I can cancel out the x plus 1 in each of these terms. And the x squared minus 4 can cancel, or can factor, to x minus 2 times x plus 2. However, none of those is going to cancel with the 2x above. So I'm going to leave my answer as 2x over x squared minus 4. You're welcome to leave that x squared minus 4 in the factored form as well, if that's what you prefer. So in Part B here, when we look to factor, I see in the numerator that I can factor out powers of a, specifically a to the third. And in the denominator, I can factor out 2a squared. And then notice how similar these two terms look. Okay? But I want you to be really careful about this 3 minus a idea. It is not the same thing as a minus 3. So 3 minus a, if you rearrange the terms in order so that a comes first, you have negative a plus 3. Then if you factor out the negative, you'll see that you have the opposite of a minus 3. Therefore, 3 minus a is related to a minus 3, but it would have to have this negative factor in front of it. So I'm going to take the problem and rewrite the 3 minus a factor as a factor of negative a minus 3. And I have my 2a squared and a minus 3. So the a minus 3's can now cancel. Don't forget that you have this negative factor here, like a negative 1. A squared can cancel all but one of the powers of a. So I have a negative a over 2 once I'm done simplifying this expression. So in Part C here, this is more of a simple exponential expression. It's already been simplified, so we don't really have to worry about Part C. I do want to go back, though, and make a note about Part A and B. I'm sorry. Just about what makes the function undefined. So I want you to notice here that because of the x squared minus 4, or these two factors, x cannot equal 2 or negative 2, because those values would create a 0 in the denominator that would be undefined. And because of the x plus 1 factor, x cannot equal negative 1. So there are actually 3 restrictions on this problem. X cannot equal negative 1, negative 2, or positive 2. And if we look at this original problem here, we can see from the denominator, values that would make the function undefined are if a was equal to 0 or if it was equal to 3. So a cannot be equal to 0 or 3. Pointing those out for a couple of reasons. One, it's important to understand, and two, as you've seen in the graphing, it becomes important about what the restrictions are. Then to address Part D, remember that if you are dividing rational expressions or fractions, so to speak, that we are multiplying by the reciprocal. And just recall how your exponent rules work. So here, a can cancel one of the powers of a, b can cancel one of the powers of b, x can cancel one of the powers of x, and y can cancel one of the powers of y. 2 goes into 8 4 times, and 5 goes into 15 3 times. So in the numerator, let's see, I'm having a hard time keeping track, so I'm just going to circle them. I have 4xb cubed, and in the denominator, I have 3ay. So I'm able to simplify. Now remember, I was able to cancel all of those because they're factors. They were all multiplying each other. I have to be a lot more cautious when addition and subtraction are involved. Okay. You can try these. If you have any questions, come into class, but those are there for you guys. So then looking at example 2, in order to simplify, When they get a little more complicated, we still want to kind of concentrate on canceling factors, which means the first thing we need to do is factor. So in the denominator, x plus 1 times x plus 3 is how that polynomial would factor. And in the numerator, x plus 4 times x minus 2 is how that polynomial would factor. Notice that nothing cancels here. So I am unable to simplify anything here. So you would just leave it like that or state that it already is simplified. In part B, it looks really complicated. As a matter of fact, they call these complex fractions sometimes. That's exactly what they look like. But notice you have a fraction being divided by another fraction. So another way to write this is to recognize that you have 5a squared minus 20 over 2a plus 2, which is being divided by 10a minus 20 over 4a. So I'm going to factor 2 times a plus 1, each expression that I can. So you see I'm almost fully factored. This can factor further, and then I also want to proceed with the normal ways that I would divide rationals. So it's a minus 2 and a plus 2, 2 times a plus 1. I'm going to change the division to multiplication, and I'm going to use the reciprocal of the divisor. So then when I look closely at the factors, I see a factor of a minus 2 can cancel, that 5 goes into 10 2 times, that 2 goes into 4 2 times, and then those factors of 2 can cancel. So I appear to be left with a factor of a and a plus 2 in the numerator, and a factor of just a plus 1 in the denominator. You can keep them in factored form for your final answer, but just be aware that if someone wrote the answer differently, you can recognize whether it's been factored or distributed. All right, so again, there's a couple try these problems. If you have any questions, then come in and ask. So hopefully this was a good kind of quick review on simplifying, multiplying, and dividing rational expressions.